Hello, everyone. Today we'll be going over the solution to declining invitations from the USACO January 2026 silver contest. So in this problem, you're given that there are n contestants, and each of them satisfies some subset of uh, like a total of C criteria. So for example, in this sample test case, we have five contestants. The first contestant satisfies criteria one. The second contestant satisfies criteria one and two, and so on for each of the five contestants. And these contestants will be invited based on like a specific process. So first there's like an array F, which represents like the number of contestants invited based on each criteria. And essentially you'll go from the lowest criteria to the highest criteria and invite that many like contestants. And we're inviting the contestants with the lowest index. We're prioritizing those contestants. So for example, how that would go in this test case is we have the first, we're selecting one contestant under criteria one. So we select the lowest index contestant who satisfies that criteria, which is contestant one. And then under criteria two, we select the lowest contestant, which is contestant two, and so on. And we can see that we'll select contestant three next, and then contestant four. So we'll end up inviting the first four contestants. And essentially, uh, we want to keep track of like the sum of the indexes of these contestants. So in this case, the sum would be 10, 1 plus 2 plus 3 plus 4. But there's also this additional like um, problem where contestants might decline their invitation. And so that's described by this array P where it describes the order in which contestants decline. So in this case, initially contestant one will decline, and then contestant two will decline, and so on. And these like declinations are cumulative, so they will stack up. So eventually at the end, all the contestants will decline. And what we want to do is like once a contestant declines, it's essentially as if like they're removed from like the leaderboard, and the process is like rerun without their like without them. So without like the criteria they satisfy. And so we just want to keep track of how like the sum of the indexes of the contestants we invite after each contestant declines. So for example, after contestant one declines, we're going to repeat the same process to figure out who we're going to invite. So first we're going to invite one person under criteria one, and that's contestant two. Then we'll invite one person under criteria two, and we can't invite the same person twice. So the next person will be contestant three, who would be invited under criteria two. And if we continue the process, we'll see that we'll end up inviting contestants three or contestants two to five. And the sum of their like indexes is 14. So the answer would after the sum of their like ranks of each of these contestants after contestant one declines would be 14. So our goal is to after each contestant declines, we need to update the answer and we need to do that efficiently. But first, before we solve that problem, it's helpful to solve a simpler version of the problem where if no one declines, how would we uh find out like who is invited and like the sum of the indexes of the people who are invited. So we can make an observation that we can essentially like simulate the process they described, right? So we can loop over criteria in increasing order from 1 to C. Then we look at like all the contestants that satisfy criteria I, and we invite the top F sub I of them that we haven't invited yet. So um, yeah, the way we do that is by uh, like we would keep track of if we have invited a contestant or not, and we would just go in order from lowest to highest index and invite the next if we can. And now we need to figure out what happens if one person declines, right? The next person decline. What if they decline their invitation? What will happen? And the key idea is like we don't have to redo it from scratch, right? We don't have to redo this process. We can, and not everything changes when one person declines. So we can make an observation. There's like several cases that could happen, right? So the first case is if the person who declined wasn't invited in the first place, then nothing happens. We don't change like the set of people who were invited. But otherwise, the person was invited and declined their invitation. So we need to like replace them. And let's say they were invited under criteria I. There's three things that can happen now. If there's no one else that's like not already invited that satisfies this criteria I, then there's no one else who can be like replace that contestant who just declined. So no one else is invited. Otherwise, in case two, uh, there is someone else who satisfies criteria I and they weren't previously invited. So after this contestant declines, they're like the perfect replacement and they weren't invited previously. So we can just like update the answer with their like index. And the third case is the trickiest where we have a replacement, but the person like the next highest person who satisfied criteria I was already invited based on a different criteria J. And essentially the reason this is tricky is because now we need to find a replacement for uh, the criteria J, right? And so essentially there's like this chain effect of where we need to find a replacement for a replacement and so on. Yeah, so some like ideas on how to implement this. This like process sort of is like describes like a queue. We want to find the next person in line for each criteria. So we can for each criteria we can keep a queue in like sorted order of like the next person who wasn't invited yet. And we can also keep track of each contestant, like the criteria they're invited under. So like we would be able to tell what criteria I that the person who declined was originally invited under. And with these two like techniques, we can check case one and case two pretty quickly. But case three is still tricky for the same reason. Like we have to find replacements of replacements, um, and so on, which is not very clear how to do that. So yeah, zooming in on case three a bit more, we can see that we can make observation that there are like two cases with that. So the first, yeah, so for case three, assume that the next person who has to replace, uh, like the next highest person for criteria I who has to replace the contestant that just declined. Let's say they were already invited based on a different criteria J. So if J is less than I, so if they were actually invited on an earlier criteria, then since they're already invited by the time we reach criteria I, this person, like the next person in line, can't be invited. So they won't be the replacement. We have to keep looking. But otherwise, this person is now like J is greater than I, and this person will now be invited under criteria I instead of criteria J. And so this opens up another spot for another contestant to be invited under criteria J. And the key idea is in this latter case, we can use recursion to fill the spot that was opened, right? So we found a replacement for the opening in criteria I, and that opened up a spot in criteria J, and we can recurse there to find a replacement for that spot. And the reason this works and it's like runs fast enough is because J is greater than I. So we are moving to a strictly like later, a strictly higher criteria. And this will eventually end, right? We can't go forever because we'll run out of criteria eventually. And the number of recursion, like the number of times we need to recurse, is actually just like the sum of n over all contestants. So that this is essentially like the sum of the number of criteria each contestant satisfies, like over all possible contestants. And that's the maximum number of times we need to recurse. And so since that's like constrained by the input, this like using recursion to fill up the spot will run fast enough. And so this allows us to code up a solution just by keeping these like this queue and like this like list of the invitations and processing these cases. So first we'll read in the input. And since we need a queue, we'll import that using the Python library. And the first thing we'll do is we'll make the queue for each criteria, right? So for each criteria, we'll insert the contestants into the queue based on like the order from lowest to highest index. And then we'll find the initial answer before anyone declines. So here we'll store like where the criteria each contestant was invited under, and we'll go through from criteria lowest to highest criteria, and essentially we're gonna try to fill up the quota of F sub I contestants, um, or like until we run out of contestants that satisfy that criteria. Whichever of those two come first, we'll do that, and then we'll essentially like pop from the left of the queue. So we'll take like the lowest index contestant from the queue, and we'll fill up our uh, like invitations based on that. We'll record like for each contestant the criteria they were invited under, and we'll also update the answer. So now we are going to process like contestants declining, right? So we'll keep a set of uh contestants declining, and we'll loop over each of the order, like each of the contestants in the order they decline. So P is the order that the contestants decline. So now we need to process when contestant X declines their invitation. So first we print the answer. We need to print the answer before each contestant declines. And then we're going to check if this is the case one. So if this contestant was not invited, then we don't need to do anything. We just need to like process that. Otherwise, we need to remove them from the answer since they're no longer invited. We need to like, and we need to, and now we need to update, we need to replace them under criteria J. So this is the criteria that they were invited under. And we can do a for loop to sort of simulate the recursion that we do. So first we take the next replacement. And if this replacement had previously declined, obviously we can't use them as a replacement. So we're going to take the next person. And now if the replacement was not previously invited under any previous condition, we can like update the answer to invite them, and we can also like keep track of now that they're now invited under criteria J. And otherwise, yeah, this is like the first case where the contestant was invited but under a like smaller condition. So in this case, we can't use them as a replacement, so we're going to continue to our next option. But otherwise, now we have to use recursion. So what we're going to do is we're going to take like the new criteria that we need to find a replacement for, which is like we'll call new J, and then we'll update uh that contestant to be invited under J instead of what they were previously invited under. And we'll update to new J, and then we'll recurse uh because through this while loop. And essentially this is just implementing the solution we described here where um we're recursively like walk through these three cases, and each time we'll be printing the answer. And now we can test it on our sample to make sure it works. So we can have, and yeah, we can see that we got the correct answer. So yeah, thank you guys for watching. Hope you learned something.